Okay, this is 8F2, 8th grade functions, standard 2, video 1, comparing functions. Today we are going to be taking that idea of a function and comparing them in a couple of different ways, algebraically, graphically, numerically in a table, or using verbal descriptions. The new word that we have in our list of terms is rate of change. We are going to be talking a lot about the rate of change in this video. First screen says, does this relation have a constant rate of change? Now the rate of change primarily is known as the slope in a linear function. So if I have all of these ordered pairs in my table, all of my inputs and my outputs, the first ordered pair is 0, 0, and then I have 1, 2, 2, 4, 3, 6, and 4, 8. If I were to graph those on a grid, I'm going to be able to see what kind of relationship they have to each other. If I don't have a graph and I only have this table, I'm going to be looking for different comparisons that these inputs and outputs might have to each other. So let's just take the first example and notice the X column. So as I move downward in the X column, I'm noticing that each time I move downward, we are increasing by 1. So if I were to say this verbally, as my X values increase by 1, what is happening to my Y values? Well, let's look and see if there's any type of comparison in the Y column. So as I increase my X's by 1, it looks like each time I go down my Y column, I am increasing by 2. And that's called a constant rate of change because it's constantly doing the same thing in each column. Again, as X increases by 1, my Y increases by 2. Now let's look at the second example and see if that is the same. So looking at my X column, I notice that I'm increasing again by 1. It doesn't always have to be by 1, but in these examples I have that. So as my X's are increasing by 1, what's happening to my Y values? Do we have a constant change? Well, it looks like when I go from my first set of my first ordered pair to my second one, I'm increasing by 1. So if it was constantly changing, the next one should have also been an increase of 1, and it wasn't. It was actually an increase of 3. The next one was an increase of 5, and then I went from 9 to 16, which was an increase of 7. It does have a specific pattern, but it's not the same rate of change. It's not constant. So that's why this is not a constant rate of change, and the first one is a constant rate of change. And again, we're dealing with the slope of the line. If I were to graph these, let's just say I have a line like this. It is telling me how much slope it has. So if you're going skiing, how steep is that particular hill that you're skiing down? What is the rate of change? So as I'm increasing my X values, what's happening to my Y values? As I go to the right, I'm going up. Is it a constant change all across the line? We're going to get more into that here in the next slide. Okay, now we're going to go through a couple of examples in which we are going to follow the standard and compare different types of functions and looking at their rate of change. All right. The main player in all of this is this equation of a line called slope-intercept form, in which we have y equaling mx plus b. And for today's purposes, I'm just going to tell you a little bit about this equation. The b here isn't going to play much of a factor in determining the rate of change. This B is called the y-intercept. I'll write that down. And basically, when we graph a line using all those ordered pairs, this y-intercept is where the line is going to cross the y-axis. So we are intercepting the line right at this point. Again, I'll just say for today's purpose, the B does not play any factor into what our rate of change is going to be. Now, what does play a factor in the rate of change is this variable called m. And m is called the slope of the line. That is how steep the line is. Whether it is in a positive fashion or if it were to be negative, that doesn't matter in terms of the rate of change. What does matter is how steep the rate of change is, or how large the rate of change is. And then just to talk about these other variables called x and y, if we were to graph this pink line here, the x and the y are all of these ordered pairs from this previous page if we were to take one of these examples. So I would plug in the x value into the equation, and then this is the y value. So don't mix up this y-intercept and this y coordinate. All right, now let's get into the bulk of the lesson here. If I'm comparing the rate of change in A to B, A is graphically and B is algebraically. It has variables in there. That's what makes it algebraic. We are going to look at the slope. So if I have 2 points on the line, these are my intercepts, I can say if I were to go from point X to point, no, let's not use X. We always use X. Let's go from point M to point N. To get from M to N, I could go two different ways. I'm going to start with the X value first. So I'm going to the right. Let's see, 1, 2, 3, 4. So what they're saying is X, as X is increasing by 4, what's happening to my Y values? Well, as I go to the right or increase by 4, my Y values are increasing by 3. So if I were to say my slope M is equal to, now we always did the rise over the run. We've talked about that in the past. My M in part A is going to be as my X, my run is my X axis. As my X increases by 4, my Y values are all going to increase by 3. So part A is a fraction of 3/4. All right. In part B, they already give us the M. I don't have to do very much work. I'm in my slope-intercept form. Y equals mx and b. So I have to take my m value and turn it into this fraction. So my rise over my run, my rate of change here, is -2 over 1. Because if I have a -2, I need to make sure it remains a negative number here, a negative fraction. So I'd have to put it over a 1. And if I were to kind of compare it to the A, the wording I was using, as I increase my X by 1, I am decreasing every time by 2 units. So if I come down here, I have -2 over 1. Now, these two answers for A and B are going to tell you how steep your line is, or if we're talking about skiing, how steep is the slope that you're going down. It doesn't matter if it's positive or negative, because if you think about hills, one hill on the ski slope might be aiming to the north and the other ski slope is aiming to the south. They're still going to be pretty steep hills. So which one is more steep, or which one has the greater rate of change? So in this case, we're just looking at the positives. So let's just take the absolute value of each of them, and that will turn them into positives. Okay, so the absolute value of 3/4 remains 3/4, and the absolute value of -2 is +2. And who's greater? Which is the greater value? Well, 2 is greater than 3/4, so that means B has the greater rate of change. Okay. Now we are comparing, again, according to the standard, we're going to be comparing these table values to an algebraic equation using algebra here. So let's see if we have this pattern on A. Starting in our X column, we go from -2 to 1 and 1 to 4. So when it comes to our rate of change, my M is equal to, well, we're adding 3. So if I'm looking at my X column, my run is in the bottom. Every time I add 3, we are, see, does it follow the same constant rate of change? It is a constant rate of change because we are adding 6 each time we move down. So as we increase our X values by 3, we are increasing our Y values by 6. So M is equal to, let's reduce this, 6 divided by 3 is 2. And in part B, looks like we have to rearrange this equation, and we're going to have to do a lot of these in class, rearranging our equation to put into slope-intercept form. But we need it to look like y is equal to mx plus b. So focus in here. We've talked about rearranging equations in the past. So we draw the wall. We're going to keep our y value on the left according to our equation. So let's stabilize that y value. And now we need to bring this term 5x to the right. So anytime you throw a whole term to the other side of the equal sign, we have to change the sign. So it becomes -5x. And then we are keeping our 9 on the right. We don't want it near the y. We wanted y by itself. So we didn't move the 9, so it stays 9. And one more part here. We want y to be by itself. It's attached to a -3. So to undo that multiplication of a -3, the inverse operation is dividing by -3. That will get rid of it. And we have to balance the equation and do that to each of the terms on the other side. So if I divide by -3, I divide by -3, and I divide by -3. And where does that leave us? Well, if I were to simplify this fraction, a negative divided by a negative is a positive. A 3 divided by 3 is 1. So I'm left with +1y, which is exactly what I wanted up here. And now I have a negative divided by a negative again. I have 5 divided by 3. And the last part, +9 divided by -3 is a -3. So looking at my slope here, my rate of change in this B category, I have 5/3. So my M is equal to 5/3. Now if we're comparing these two, again, we're only looking at the positive values. So let's take the absolute value. The absolute value of 2 is 2. And the absolute value of 5/3 is 5/3, but let's change that into a mixed number. So 5 divided by 3 is 1, with 2 left over. So that's really 1 2/3. Now, who's a greater rate of change? Well, that would be 2 is greater than 1 2/3. So A, after all that work, has the greater rate of change. It is a steeper slope. Okay, last one. Now we have this comparison from the standard that says let's use a verbal description and compare it to an algebraic equation. All right, so we're looking for m, that's our rise over run, and it says the y-intercept is 6. Okay, well that's great information if we were graphing the line. But if I'm finding the constant rate of change, or this, what rate of change is the largest, that 6, that y-intercept, won't play a factor in this problem. So I'm just going to focus in on these words that say, as x increases by 2, my run, my y increases by 1. That's my rise. Increases by 1. So that means I have 1/2 compared to, let's look at B. Oh, thank you. They set it up for us. Y equals mx plus b. Okay, so that means I have m equaling 4/7. So I'm going to be comparing 4/7 to 1/2. And if you wanted to take your absolute values, they were both positive anyway, so that won't matter. So now we're comparing 1/2 to 4/7. Well, we know what 1 out of 2 is. How does that compare to 4 out of 7? Well, what's a half of 7? 3.5. So 4 is greater than 3.5, which makes this fraction greater. So it has a greater rate of change. Okay, in your journals, I'd like you to define the given terms and write a few sentences on what you learned from this video. When you get to class, we are going to talk at length about rearranging this equation called slope-intercept form, also known as y equals mx plus b. And again, I think if there's any difficult part in this lesson, it will come from that part. We need to figure out what the slope of the line is. Okay, I will answer all your questions in class.